Okay, today's lesson is 13-5, solving trigonometric equations. This is the last section of our trig chapter. Some of y'all might be thrilled, some of you might be sad, but we are going to take everything that we've learned over these last two chapters and make sure we can solve equations with them. So this first one of the things that you need to do when you're solving equations, you got to make sure you pay attention to the directions. And this is part of the problem is telling you how to give your answers. Okay, so pay attention to that. So this says solve 9 sine squared x plus 2 equal to 3 over the interval of x between 0 and 2 pi. Okay, so first and foremost, you want to always isolate your trig function. So to isolate that, I'm going to take the 2 to the other side, and that of course gives me 9 sine x squared equal to 1. Then I'm going to divide by 9. Sine x squared equals 1/9, and then I'm going to take the square root of both sides, and sine of x equals plus or minus 1/3. Now, that is not a value from our unit circle, so you will have to use a calculator. Now, the other thing to pay attention to is if it says between 0 and 2 pi, then your calculator needs to be in radians. Okay, now I find it very helpful to have a visual. So if sine of x equals plus or minus 1/3, then I'm going to remember that the sign is positive in the first two quadrants and negative in the third and fourth quadrant. Okay, so when you put it in your calculator is giving you a number of x equals, the first one it's going to give you is 0.34. So I'm going to remind you, okay, of a couple things that, as I showed you, if you have a plus or minus, a sine or cosine value plus or minus, then you want to remember that you're going to have 4 times between 0 and 2 pi, because these two quadrants, sine is positive, these two, they're negative, as I just said. So if the calculator gives me 0.3, this is the concept of that reference angle that's coming in. So each of those, I showed you what the reference angle was, but remember, you always have to name it from this point here, from the 0 axis. So that first one, the first quadrant, is 0.34. Okay. In the second quadrant, I'm going to go, what is this number over here, y'all? It is pi. As a decimal, that is 3.14. So I'm going to take 3.14 and I'm going to go 0.34 before it, which means that's 3.14 minus 0.34, which is 2.8. And then in the third quadrant, I'm going to go 3.14 plus 0.34. And in the last one, I have to use 2 pi, and 2 pi, which is 2 times 3.14, or 6.28. And 6.28 minus 0.34 is going to give me 5.94. So those are your 4 answers to that problem. Okay, now, those are specific answers between only that interval. All right, this next problem says find the general solution. So this is kind of remembering from your graphing. When I graph the cosine, y'all, it's going up and down and up and down and up and down forever and ever. So we're going to figure out how to write all of those solutions for this particular problem. Okay, same thing we start off with. Again, it's going to be in degrees. We're going to start off with 4 cosine x plus 1 equals -1. You want to isolate your trig function, so I'm going to subtract 1 from both sides. Then I'm going to divide by 4. Cosine of x equals -1/2. So where's the cosine negative? In the second and the fourth quadrant. Okay, so what is it? -1/2 is on my unit circle. So that means that the one in the second quadrant, and actually made it green, worked out this time. That's color-coded our green on our unit circle. So that is, 2 pi over 3, except for they want it in degrees. So I'm going to say x equals 120 degrees. Now, if I need the general solution of that, y'all, okay, then every time I'm going to go around the circle to get back to that point, and that's 360 degrees. And an easy way to do that is just to remember what the period is of your cosine function. So I have 120 plus 360 in, and if I go down to that third quadrant, that's 240 degrees again, plus my period times n. So that's the difference between having a general solution and one over a specific interval. You're adding back the period, any multiple of the period. That's what the n is telling us. It can be an integer there. Okay, so another find the general solutions. This time it's in radians. So I have sine of x equals tangent squared x, sine of x tangent squared x equals sine of x. Okay, I have more than one trig function. That was the difference in those first two. So if I have more than one trig function, I'm going to try to bring it over to one side and see that I have a common factor. Do not ever divide if it makes it go away. So I bring it to one side. If you had divided both sides by sine of x, you would end up with tangent squared equals 1, and you wouldn't have all the solutions to the problem. So that's why you never want to divide by a variable if it totally goes away. So from this point, I have a common factor of the sine of x. So I'm going to factor out sine of x equals tangent squared x minus, golly, what is my problem? Sine of x times tangent squared x minus 1 equals 0. I'm going to set each factor equal to 0. And I kind of jumped a step, set it equal to 0, bring the 1 over, take the square to both sides. My bad. Okay, but I'm going to tackle each one of these. Where's the sign 0? Again, I like that unit circle. I'm thinking the sign is 0 there and there. Okay, now back up here, y'all. I had 2 points on the circle, but those points were not directly across from each other. So if they are not directly across from each other, I have to list each one separately and then add all the way around the circle. But if they are directly across from each other, then I can just name one of them. And then how far apart are they? They're not 2 pi apart. They are pi n. So this one, the first answer is going to be x equals pi n. So that's for the sine of x equal to 0. Now, tangent of x equals plus or minus 1. Okay, that's that plus or minus, and the tangent equals 1 in 2 quadrants, so plus or minus is going to be 4 quadrants. So that is where it always, where they show up. Now, you have 2 options. You can list each one of those answers separately, just like we did up here, and add 360 in. But because they are directly across from each other, which will always be the case with tangent and cotangent, then I only have to name one of them and say plus pi n, or 180 n if we were doing degrees. So this first one in the first quadrant is pi over 4 plus pi n. And the one in the second quadrant, so the other one I named, so if I name pi over 4 plus pi n gets this one. So I've taken care of these 2. And now you can name either one of those. I choose to name 3 pi over 4 and again add pi n because they are directly across from each other. Okay? All right, so another type, get into a little more complicated. Okay, solve cosine squared x minus 4 cosine x plus 1 equals 0 over the interval from 0 to 2 pi. Now, in this particular case, what makes it a little different than what we've had before, I do have all the same trig function, but I have a squared this time. So this is one that in math, they often use the letter u to describe a process called u substitution. And I'm going to let u equal the cosine of x. I'm picking the one that's not squared. So if u equals the cosine of x, then u squared equals cosine squared x. And that means that this particular equation can be written more simply as that. Okay, the first part, u squared, because that's if I square both of those. So cosine squared is u squared, minus 4 cosine is u, and then the 1 doesn't change. And then you factor it solve it like any quadratic that you've done in the past. I like completing the square if my b value, this number here, if it is an even number and this is 1, easiest thing for me is completing the square, much more so than quadratic formula. It doesn't factor because there's no factors of 1 that add to give me 4. So completing the square, remember we start off like that. We move the 1 to the other side, and then we put the blanks. And I take 1/2 of my b value, which is 2. 1/2 of 4 is 2, and I square it. And I always ignore the negative because when you square the numbers, it's always going to be positive. And then I multiply it out over here and I get 4. So my left side factors to a perfect square. My right side simplifies to 3. And when I take the square root of both sides, I get, and bring the 2 over, I get u equals 2 plus or minus the square root of 3. Now, those are not values. Well, actually, let's go period. I know, remember, y'all, that u is equal to the cosine of x. We don't have any cosine of x equal to that number. So I'm going to go get the decimal approximations of them. So that is u equals 3.73 or u equals 0.27. Okay. Now, what does u equal? U is the cosine of x. So where's the cosine equal to 3.73? And you're going to say never, because you remember the cosine is always between -1 and 1. So if you ever get anything outside of that, bigger than 1 or less than -1, then you don't have to worry about it. Okay. Now, on the other hand, cosine of x equal to 0.27. That, of course, is between 1 and -1. So I'm going to use my calculator to get that because it is not on my unit circle. And because it says between 0 and 2 pi, I'm going to have to use my calculator and make sure my calculator is in radians. So cosine is positive in which 2 quadrants? First and third. So when you put it in your calculator, it told you 1.3. Okay, and the other one is down below, so that's going to be 6.28 minus 1.3. That's how we get the one in the fourth quadrant. Okay, moving right along. Let's do another one of those. We have solve sine squared x minus 3 sine x minus 2 equals 3 over the interval from 0 to 2 pi. Again, y'all, you see a sine squared, okay? That's quadratic-like, which means that I need to set it equal to 0. So I'm going to subtract 3 from both sides to set it equal to 0. I am using the substitution. You are more than welcome to factor this thing without it if you're a really good factorer and can see it. Okay, but I'm going to go ahead, let u equal the sine of x because I choose that middle term. So when you square both sides, u squared equals sine squared. So that means this is going to be u squared minus 3u minus 5. Okay, I'm still going to complete the square because I don't like the quadratic formula so much. People just tend to make mistakes. So I'm going to do it with this. It's not so bad. So remember, I'm going to set it up by taking the 5 to the other side and drawing my blanks. And then I take half of 3 and square it, and 3 halves squared is 9/4. And then I factor it, simplify the right side, and then I'm going to take the square root of both sides, and of course, always remember my plus or minus. Now, again, clearly not any values on the unit circle, so I'm going to get decimal approximations of those numbers. So 3 halves plus the square root of 29 over 2 is 4.9. And 3 halves minus the square root of 29 over 2 is negative 1.19. Again, what does u equal? U equals the sine of x. So where's the sine equal to 4.19? Never. Where's the sine equal to negative 1.9? Again, not ever. So I didn't box it on the first one, y'all, because I had the possibility over here. But negative 1.19, again, outside of that range of being between 1 and negative 1. So there's no solution to this problem. And, you know, if you're really interested, you could go graph these things. The best way to check them, graph it, set, and then graph y equals 3, and you will see that they will never cross each other on a graph. Okay, now the last two examples that we have, I want you to be aware of. Notice something different. Solve 1 plus tan x equals square root of 2 secant x over the interval of 0 to 2 pi. Okay, so what is important about these is you always need to make sure that you have the same trig function. I do not have the same trig function and the same angle. So I'm doing one where it's not all the same trig function. There's tangent, that's secant. And down here, that says 2x and that says x. So that's an example of when I don't have the same angle. So I'm doing one of each. Okay, so how do I handle this? I don't have any substitution of tangent x. I have it sine over cosine. And that's 1 over cosine. Okay, secant is 1 over cosine. So you could go ahead and convert everything to sine and cosine. It would be a much lengthier problem. But if you remember your Pythagorean identities and know that there is one that involves tangent and secant together, then you hopefully will remember that the best way to handle this is to take both sides of your equation and square it. So when I square the left side, that's a PST, okay? So I'm going to get 1 plus 2 tan x plus tangent squared x. And when I square the right side, I get square root of 2 times the secant squared of x. Now, this is your Pythagorean identity. Since I have a tan squared and a tangent, I want to get rid of this guy. So I'm going to remember that secant squared is equal to 1 plus tangent squared. So instead of the secant squared, I substituted this because of my Pythagorean identities. Now I'm going to distribute that 2 and bring everything to one side because I have a squared term, and that's what you get. That is 2 plus 2 tangent squared. Okay, and when I subtract this, I get tangent squared. When I bring that over, it becomes minus 2 tan x, and 2 minus 1 equals 1. So that, I'm sure y'all remember, we'll go ahead and do it. I'm going to put in, again, I've got a u substitution because I've got a squared in there. So I'm going to let u equal the tan of x, and that becomes u squared minus 2u plus 1, which factors as a PST, u minus 1 quantity squared. So when I bring that up to the other side, then I'm going to find out that u equals 1. And what does u equal? Tangent of x. So tan of x equals 1. And where's the tangent equal to 1? Over the interval. So again, go back and look up here. If I'm supposed to be in radians or degrees, and I'm supposed to be in radians, I only need to give those between 0 and 2 pi. So my answer is pi over 4 and 5 pi over 4. In the first and the third quadrant is where the tangent's positive. Okay, last example. Solve sine of x equals, and y'all, I just noticed that this was left off. It's generally, this one is usually equals. X is equal to 0 and 2 pi. It just avoids you from giving the same answer twice, but it's generally the equals right there. So I just need to add that. All right, sine of 2x equals cosine of x. All right, remember they have to be in the same angle. So the only way I know how to change that is to use my sine double angle identity. And so that is 2 sine x cosine x equals cosine x. And just like when we did at the beginning, near the beginning, I'm going to bring it all to one side, set it equal to 0, and factor. So I apologize. I'm trying to make them faster, so I might have skipped a step there. So if you bring it over, that becomes minus cosine. When you take out the cosine, you get 2 sine x minus 1. And then I'm going to set each one equal to 0, giving me sine of x equals 0 or 1/2. So where is the sine equal to 0? At the top and the bottom. That's pi over 2 and 3 pi over 2. Where's the sine 1/2? In the first and second quadrant, which is pi over 6 and 5 pi over 6. So that is our answer. And that is the end of 13.5, solving trigonometric equations. If you have any questions, please don't hesitate to email me or set up a Google Meet. Thank you so much, and y'all have a great day.